So hello everyone. Thank you very much for inviting me to this meeting. And today I'll introduce you to the CIBSE's online benchmarking tool. Before I do so, I'll briefly introduce myself. So my name is Dr. Songmin Hong. I'm a lecturer at UCL's Institute for Environmental Design and Engineering. So I'm involved in both teaching and research at the moment, and I'm a course director of an MSc program called Environmental Design and Engineering. I'm a building scientist by background, and my research focuses on taking a data-driven approach for understanding how buildings perform and understanding factors that influence the trend of energy use over time and by building types as well. And I have been involved in research projects with lots of organizations. Mainly, I'm currently collaborating with Department for Education. I've worked with Ministry of Justice and Scottish Futures Trust as well. Moving on, I'll briefly provide you with the context behind the tool and how we came about developing the tool, just to give you a better understanding of where we come from and where we're going in the future. So the need for providing better benchmarks, I think, well, has existed from back in the 1980s, I guess, after the fuel crisis in the 1970s. And there have been lots of many benchmarks that have been provided by different organizations and through various publications, namely starting with ones called Yellow Books, which were published in 1980s, followed by numerous documents published based on work by Bill Borders and others through the probe studies, for example, in the 1990s, and in early 2000s, numerous existing energy benchmarks were consolidated into a single document by the CIBSE in the form of CIBSE Guide F, which was later edited or updated in 2012, but the benchmarks in it in chapter 20, for example, remain the same. And it was only in 2008 some of the benchmarks from Guide F were updated to underpin the implementation of display energy certificate scheme. So through our research, what we've discovered in recent years, over the past 5 or 6 years, I guess, is that many of these benchmarks, which were broadly based on work from late 1990s, appear to be quite outdated now. So as you can see on the chart on the right-hand side, for example, we've been analyzing display energy certificate data to understand how the performance of buildings now compared to the benchmarks which were established and updated in 2008. And it showed that in most cases, in this particular case, these are fossil fuel use, and you can see that the current fossil thermal energy use is considerably lower than what was perceived to be normal when the benchmarks were derived when TM46 was published. Also, there's also the fact that existing benchmarks tended to be absolute in terms of figures not being able to be adjusted for any individual circumstances of buildings that determine the demand for energy. And it was only through the DEC scheme that benchmarks could be adjusted for small number of parameters, which in this case is weather adjustment, extended occupancy, and allowing for separable energy uses to be deduced from the calculation process to reflect varying demand for energy based on these parameters. What we've also noted over the past years is that data existing data landscape tends to be focused around public buildings at the moment. So this is broadly thanks to data that was made publicly available from display energy certificates, whereas what we've been finding over the past, finding quite difficult to get to, are data that describe commercial buildings. We know that the data exists, but getting access to them has been quite difficult. And based on our previous research and ongoing research, what we've realized is that there is a need to constantly review the benchmarks regularly to reflect the changes that happen over time. So this is a graph, the graph on the right-hand side, for example, which shows change in energy intensity of primary schools in England. And as you can see here, the red line shows the trend in fossil thermal energy use decreasing over more than 20 years, as opposed to the demand for electricity, which is shown as a green line, which appears to be increasing, although it seems to have plateaued in recent years, and we're starting to see the intensity going down a bit. So it's a good sign. We've also noted that existing classifications tended to be based on a small number of case studies, and through our research at stock level, what we've realized is that there are possibilities of reviewing classifications as well. So this is an example of energy use distribution curve for primary and secondary schools, and what we realized through a large data analysis is that there is an intrinsic difference in demand for heating and in electricity between primary and secondary schools, therefore suggesting that separate benchmarks should be provided for different school types rather than aggregating them into a single category. So based on these outputs, what we've sort of glimpsed at as an opportunity is to perhaps move towards a more dynamic approach to benchmarking rather than working with static sort of hard copy based benchmarks, which used to be the norm until quite recently. Another area we've noticed in terms of opportunity is to improve the relevance of benchmarking, and until recently, benchmarks tended to be based on purely activities, and in some cases they did consider variations in how the buildings were serviced in terms of ventilation and conditioning, for example. But what has become possible with introduction of large publicly accessible data sets such as DECs, for example, is a possibility for incorporating more parameters than just the activity type, weather and occupancy. So what we are currently looking at the moment is to try to understand different activity types and building types in their own merit and context, trying to understand whether there are any other parameters that can be introduced to contextualize the benchmarks further than how they used to be used. And this has been done through simple correlation studies, for example, and by using machine learning techniques and regression models, for example. And what we realized is that by adopting these methods to generate benchmarks that are adjusted for more than just 3 parameters would allow us to provide benchmarks that take into account a broad range of circumstances per building type. Rather than having a single method for all building types, we would then be able to have different approaches for different building types with different key determinants of energy use. Another challenge we're noticing at the moment is that most of the research projects or benchmarks tend to focus on very small number of activity types, As you can see on the right-hand side, for example, this is a distribution of floor area by activity and build form of the non-domestic building stock. And what you might be aware of or be familiar with is a concerted effort towards offices and schools in general, but there are lots of different activity types that are not being researched extensively at the moment. So knowledge on these and how they use energy remains to be discovered a bit more. And these limitations also sort of floated on an idea that we could start exploring data crowdsourcing approaches, for example, to gather data from private sector where we currently don't have reach towards and coverage to gain access to data, as well as broadening our coverage of benchmarks that the CIBSE is proposing at the moment. And to tackle all these challenges and also exploit these opportunities, we've decided to digitize the benchmarks through the development of the CIBSE benchmarking tool. It is free for everyone to use as long as you register for it. It's in the beta phase, but we are hoping to launch this as a full version quite soon. One of the other benefits of digitizing the benchmarks is that we can provide the benchmarks to broader range of stakeholders, not just engineers or architects who have reasonable knowledge or very clear understanding of the methodology and the processes, but for those who are on the softer side of facilities management, for example, such as head teachers of schools. By digitizing the benchmarking process, what we are hoping also to do is start exploring advanced methods for providing more contextualized benchmarks, as I mentioned before. And also being digital means we will be able to update the benchmarks as and when we have the data, rather than waiting for a 4 or 5 year cycle to update all the benchmarks in one go and then print them out as a single document. What we're also foreseeing and hoping to do through this tool or a platform is to use it as a venue for sharing data from the public and private sectors with users, as well as exchanging knowledge between the users themselves. And by digitizing the benchmarking data, we're hoping to help designers and engineers improve the building operation as well. And what we've done through the tool is to provide a distribution curve which provides different benchmarking points or more benchmarking points than you would have had access to in a typical way. So in traditionally, well, at least in the UK anyway, what you would have had access to through benchmarking documents are typical performance and good practice performance points, which related to median and lower quartile, whereas by recognizing the fact that there could be a lot of different stakeholders and different positions which could benefit from different range of targets, which either go beyond or below the median or lower quartile, so that for those in different situations, we've decided that it would be best to provide a whole distribution curve to help those in different circumstances. And through the tool, what we're hoping to do at the moment, there is a very simple way to set the targets by superimposing the target over the distribution curve, just to provide an idea of where a particular performance figure stands in relation to the relevant population. Okay, so yeah, this is the point. This is a point I've already covered. So I'll move on to the next slide. The project is a multi-phase project. So what I'm going to demonstrate today is a finished product of phase 1, which focused on establishing the framework, which includes processing engine and the user interface itself. And we're now in the process of moving to the second phase, which focuses on engaging users to develop the crowdsourcing aspect. So this is a simple overview of the phase 1. So what we had to do during the first year of the development phase was to think about the data sources, where they come from, and how, in which format they were provided, and then trying to link that with the sort of processing side of things, which includes data being fed into a processing engine, which then generates the statistical points, which is projected onto the front end of the platform. So establishing the framework itself took quite a while to troubleshoot all the issues because, well, we simply didn't have the expertise or experience to do this. Whereas now I think we're reasonably familiar with the process, and so we are sort of confident to move on to the next phase. One of the key focuses of phase 2 and moving on to phase 1 and moving on to phase 2 will be to improve the relevance of comparison. And this is in recognition of the variation in building characteristics that tend to have impact on intrinsic sort of demand for energy, which can be associated with build form, age, and different types of building services, for example. And what we're hoping, well, what we have been doing and what we're hoping to implement in the future is to combine data-driven methods such as machine learning techniques or regression models, for example, with a bottom-up method such as dynamic simulation model outputs to provide a contextualized benchmark in using a hybrid method of these different approaches. We're also hoping to improve the relevance by developing better classifications for different schools or buildings, with different factors that determine the demand for energy, and yeah, improve the contextualization. This is still some way away, simply because of the lack of data we have access to, but naturally what we're hoping to do is move on from annualized energy benchmarks to end-use benchmarks, and hopefully towards sub-hourly benchmarks as and when the data becomes available. And this is one of the benefits we see in moving online rather than sticking with hard copy-based benchmarking documents. And to support this platform, what we're constantly doing from UCL point of view and a research collaboration to the project is to sort of base the benchmarks based on our research rather than simply just processing the data. So all the benchmarks that have been published so far would have been included in our publications, so that there is a sense of transparency to where the data comes from and how they were generated, which we think is the key to the success of the publicly available benchmarks and to raise the credibility as well. Moving on to the second phase of the project, what we are hoping to do in the user interaction side is to work on two different aspects. So one aspect is to engage the designers themselves with the data we have, and also engage the users for crowdsourcing purposes. And this is a rough overview of the second phase at the moment. What we're really hoping to get to is to acquire data from the commercial side, which we don't have coverage at the moment. And by engaging the designers or facilities managers who generate data, we are hoping that we will reach a sufficient sample size and coverage to introduce commercial side benchmarks in the near future. We are also hoping to use the data to support the modeling process as well, by creating a link using an API between the benchmarking tool and modeling software such as Design Builder, for example. So rather than designers having to move onto the platform to get the benchmarks or trying to find the document, shuffle through the documents to find relevant benchmarks for a building they're modeling, what we're hoping to do is to sort of explore an approach where a modeling software will have a built-in sort of plugin which will project the data from the benchmarking tool or the database behind it straight to the tool, so that designers can use the benchmarking data within their local environment rather than having to sort of run around trying to find the right information. Lastly, what we are hoping to do, or what I'm hoping to do from a research point of view, is to explore the concept of gamification for enhancing crowdsourcing. And to do that, what I will be exploring is to understand the opportunities and barriers that lie within the sort of commercial sector, that can be explored or that works as barriers for sharing data with the CIBSE or any other organizations anonymously for the public benefit. And to do that, I'll be creating a group of stakeholders through which we'll have focus groups, for example, to understand these opportunities and barriers, but also explore the concept of gamification itself by developing a sort of pilot project or proof of concept application, which can be used to see how effective it might be in encouraging different stakeholders to share their data with us for updating the benchmarks. And also there will be an incentive for individuals recognized by the CIBSE, for example, for their performance awards on their individual merits if they do so. So in terms of the updates, latest updates on the tool, what we've been doing so far, and we will continue to do so, is to replace or update the benchmarks from CIBSE Guide F using data from whichever source we have acquired data from. And so far, we have introduced new benchmarks for education. So higher education side for universities based on one of our engineering doctorate projects. We have updated energy benchmarks for primary and secondary schools. We have also introduced lots of other benchmarks based on display energy certificate data. And the last development involves introducing diversity benchmarks, which I believe is the first in kind in the UK. So based on meter data from BASE, we were able to process it, model it, and generate these benchmarks based on tens or hundreds of thousands of dwellings. And you will have access to these benchmarks through the benchmarking tool now. And again, we are always open for collaboration, or if you are in a position to share data, or if you know anyone who can help us provide benchmarks for any building type, non-domestic or domestic building types in the UK, please get in touch with us or myself so we can have a chat, and we may be in a position to help you with some research aspect as well. So please feel free to let me know if you have any questions. And that's it. Thank you very much. So before we finish, what I thought I would do is perhaps to show you the tool by sharing the screen. Here we go. Hua, if you're there, would you mind confirming whether you can see the screen?
Yeah, I can see your share screen now.
Brilliant.
The CIBSE website, yeah.
Perfect. So if you register at this benchmarking tool site, this is the sort of landing page you'll notice. And on the left-hand side are all the options you'll have access to. And it's very simple interface, which is quite intentional in a way. We didn't want to overcomplicate things, especially based on our experience with Carbon Buzz, which was overly complicated and which put off a lot of people. So what we've aimed to do at the moment is to try to simplify it as much as possible, make it transparent and make it work effectively. So on the top left-hand side, what you'll see are a set of benchmarking categories. So if you're not familiar with TM46, what we've decided to do is work with a benchmark category, which is a higher level grouping of subgroup of building types. So if you wanted to, for example, find a benchmark for primary schools, you'll simply click on Education Schools, which will then introduce you to subset of building types. So when you click on that, what you'll see is a distribution curve, which displays statistical points at 5 different points of a distribution curve. And below it is a table which shows you the typical sort of benchmark used by the CIBSE. And if you wanted to switch, if you're interested in looking at different benchmarks for different fuel types, for example, the default is electricity. And if you click on the fossil button, and then the graph will update itself to show you different benchmarks for different points based on fossil fuel. And below that is a spatial resolution, which also helps you with benchmarking energy use by different region of England. And this is only available at the moment to schools simply because we have sufficient data to disaggregate the data by regions at the moment. But for those building types which we don't have enough data for, this option will not be available until we get enough data points. So this is an example of a higher education benchmark, for example, and as you can see, classification has been updated in recognition of variation in activity types and combination of activities that occur in higher education facilities. And if you wanted to, for example, so if we go back to schools, and if you wanted to, for example, compare or understand where different targets from different documents for sort of how they relate to in relation to the distribution curve, for example. So this is Letty's Climate Emergency Design Guidance document, which sets out different operational energy targets for different building types. And here, for example, you can see for large scale, medium and large scale housing, the sort of target energy consumption is 35 kilowatt hours per square meter. And for heating, they're limiting, what they're just suggesting that heating should be limited to 15 kilowatt hours per square meter per year, which I think is very low. But if you wanted to compare that and see how that relates to the actual energy use from different houses, what is quite challenging in this case is because we have decided to introduce benchmarks with different dwelling types or archetypes, whereas Letty's target doesn't really define what sort of dwelling it is. So trying to relate that figure to different domestic building types would be quite a bit of challenge. But if we did want to compare it, so the target here, for example, was 35 and heating was 15 kilowatt hours per square meter, then what we can do is in this box, you can simply, that's somehow not working at the moment. That is strange. Sorry, let me try this again. Okay, so it's working here. So I think for overall, you'd be looking at around 20 kilowatt hours per square meter. So for dwelling, it seems as though the target falls somewhere between 10th and 25th percentile, which may not be too much of a push. But if you wanted to set your target based on these statistical points, then you can sort of understand where that target lies. And the last function we have on the tool at the moment is related to annual downloads. Because we're planning to update the benchmarks as and when new data comes across to us. What we're hoping to do through this function is to capture or generate a snapshot of the benchmarks we proposed in a particular year, so that you can always go back to that particular year to see what the suggested benchmarks were back then, rather than having a sort of moving goalpost, which may result from a benchmark for example, public houses being updated at each of the years. And you can download a PDF version of it if you're interested. And you can also filter the PDF file to get an overview by different categories and variables. I hope that was helpful. And if you have any questions, I'll be happy to answer any questions you might have. Thank you very much.
Thank you, Dr. Hong, and all of the participants. If you have any question, you can feel free ask that. And I think our chair also here.
Yeah.
Jerry, yeah, do you have?
Yeah, thank you. Well, apologies, I got stuck on the dual carriageway in some traffic and I couldn't. So I do apologise for being late. Thank you, but I did manage to jump in and catch most of your presentation, so that was very good. Thank you very much. Very useful. I did actually do a little bit of looking at carbon buzzers and know what you mean by saying it was quite onerous to start putting new information in. So it'll be quite interesting to see how people can start inputting into this tool as well. And like I said, now I've got your email, I can actually forward it to some of the people I know who work at local authorities and universities who might feed some of their information back in. Are we looking at, because this also includes operational energy as well, though, doesn't it?
Yes, it is. It is only operational energy at the moment. Yeah.
So there's still that disconnect between modelling and operational energy at the moment.
Yes. So yeah, it's a difficult, tricky thing to tackle. I think that. Yes. Yeah, Carbon Buzz was trying to tackle it in some way, but then it just sort of grew organically into something that was just very, very complicated and demanding. And if we've recently analyzed this sort of input data and realized that hardly anyone ever really ventured more than, well, had input more than 30% of what the platform was asking for, and most of the cases was, you know, less than 10% of all the variables that were there. So based on that, we've decided then perhaps for this one, we'll move on to the simpler side of things and then try to build gradually towards something that can function and support day-to-day sort of activities.
Yes. No, I do think it's good. I signed up to it early on in its beta testing because I realised a lot of the benchmarks are out of date as well.
Yes, yes. Yeah. If you have anyone with data that they're happy to share, then it would be really, really helpful.
Yeah. We've got a question from Abdul Ghaffar. It's got under fuel classification. How are the buildings having electric heating differentiated from those using fossil fuel?
Yes, that's a very good question. And we have received many requests for electrically heated buildings. What's quite difficult, I think, at the moment is even mainly electrically heated buildings tend to have some fossil fuel use these days, and trying to differentiate these buildings from sort of traditionally mixed-use buildings has been quite difficult. But what we are planning to do is for those build records or data sets, we are very clear about being all electric, for example. What we're hoping to do is introduce benchmarks for those sort of all electric buildings in the future, so that at least, even if a building has some fossil fuel usage, they'll be able to use the sort of fully electrical benchmarks to assess their efficiency for the electricity side of things.
Yeah, it is, because things are heading that way anyway.
Yes, and I've been noticing that all the design targets being set by different organizations tend to be a single figure rather than per fuel, which tends to, I mean, it sort of complicates things in a way, because you don't really know the composition of different fuels contributing towards that target. But then if you consider buildings becoming fully electrified, then a single figure makes more sense.
Yeah, that's very good. I don't know if one of the questions that did come in said, can you share your presentation?
Yes.
If you can share a PDF with us, we'll get that uploaded onto our website so people can download it once you've done.
Yep.
How many police stations have been used to form the police station benchmark? So data is from DEX. I'm assuming a lot of your data is from the DEX at the moment, is that?
Yes. So the benchmarking tool, so the graph on the benchmarking tool for police stations at the moment is based on 456 records from DEX. The numbers are slightly, or sometimes considerably lower than the raw data itself, because we go through a sort of rigorous process of filtering data to make sure we're only presenting data based on what we think are sensible and reliable. So we tend to exclude quite a bit of DEX, even though they are from the mandatory scheme. But yeah, so there are more than 400 records behind the police station benchmarks at the moment.
Yeah, and I think that's it. Another one typing. Yep, thank you.
Dr. Hong, you did call for the participant of your new research about that gamification thing. So it's for the general public, like a student, a lot of new generation interesting about that kind of game things. Yeah.
So yeah, so for the initial phase, I think I'll aim for stakeholders in the industry, so professionals who deal with data on a day-to-day basis rather than students. But then for the impact side and knowledge transfer, I think that's when I'll probably start thinking about engaging students and the public with the idea and the concept of it.
Okay, thank you. Yeah. So they can be potentially be a training or education tool eventually. Yeah.
Yes. Yeah.
I think another question here.
Yes. So that's a good question. So good practice traditionally tended to be the sort of lower quartile or the 25th percentile of a distribution curve. And typical practice tends to be median or 50th percentile. Those are the 2 points that have been used widely and historically in the UK, at least until now. And what we're hoping to do is try to provide more data points across the distribution. And in the second phase of the project, what we will then allow is for users to upload their data, create their project profiles, and then for those buildings that have the records uploaded onto the platform, they'll be then be able to superimpose those performance figures against the distribution curve to get the percentile points that they belong to in relation to the population. So, well, so outlier is an interesting one. It really depends on how you define it, I think. In our case, the sort of threshold for determining outliers were quite generous, perhaps, or lenient in a way. So we, for example, used floor areas as threshold. So if a deck had a floor area of less than 50 square meters, we have excluded them from the analysis, for example. And if for those with, say, energy use intensity of more than 1,000 kilowatt hours per square meter, for example, which is quite extreme, but also in some cases quite plausible. So we've used different criteria for filtering out the sort of outliers or what we believe are not typical of those building types. I hope that makes sense. And yeah, in terms of the percentage, I can't remember it on top of my head, but percentage was quite low. Generally, we did try to include as many data points as possible.
I think that's very good. Thank you very much.
Well, thank you for inviting me.
I'd like to thank everybody else for turning up as well.
Yeah, hopefully it was useful. Yes.
Yeah, and I think, like you say, it's definitely something that we're going to have to start using more as well, based on. I mean, I've attended a few CPDs recently and events recently where we're looking at the existing stock and improving it, and the paths to net zero, and you can only do that when you can measure where you are now.
Yes.
To improve it. So I think it's a very important piece of work, and it's very useful as well to be able to quickly go on there and see. From a designer, I can quickly jump on and see roughly where a building's performing and where it should be performing.
That's great to hear.
Thank you.
If you have any suggestions as a group or individually, please do get in touch with us. Again, suggestions such as providing benchmarks for electrically heated buildings, for example, are really valid and are helpful for us as well from a development point of view. So please feel free to get in touch if you have any suggestions at any given point.
Thank you, Dr. Hong, and we will share this video and also your PowerPoint with your contact for all of the participants, and hopefully they can contact you directly for any suggestion and any contribution.
Brilliant. Yeah, thank you very much.
Thank you.
Bye.
Bye.